Oh, yes. Okay. You guys, there are arts and crafts. They also, you know, okay. Let me ask you this question. In the general scheme of life, is error good or bad?
Yeah.
Error is bad. Okay. So typically, I don't know, you guys are really smart. You could probably sit here and give me a time when an error is good, but like the Formula 409 thing. You guys know about the Formula 409 thing? You guys know what Formula 409 is? It's like a piston spray. It's like, it's got a big 409 on it. It's like, it's like the count, it's like all-purpose counter spray. Anyway, I like it because it's actually their 409th attempt at making a formula. Yeah, so that might be a time when error is good, but most of the time in life, error is bad. Okay, and we would like to decrease it. We would like to decrease error. In the case of a confidence interval, it makes this come in smaller. The margin of error are the wings out the side, right? And so if we can make that as small as possible, that's a good thing and still be confident. Not like Garfield. He had a really big margin of error on his. Okay, so how can we decrease margin of error? There are two ways. The first is not ideal. Okay, so first way is to decrease the level of confidence. Okay, so don't write this. I'm just going to use Garfield again. Garfield said, or I wasn't even him, right? It was a weatherman on the TV, but he said it was going to be somewhere between -40 and 200 degrees that day. How confident did we say we were going to be? Super confident, probably 100% confident that it's going to be somewhere between -40 degrees and 200 degrees. How confident are you, though, that it's going to be between 51 and 53 degrees?
Not very confident.
Yeah. Yeah, much, much less confident. So you have to think about your range came in a lot, and you're much less sure than you were before. There's a lot less sure. Okay, that's the one way. The other way is better. And this seems to be the answer for everything in stats. Increase your sample size. The great thing about being me and a very sad thing about being me. Not sad, just funny. I have created two very cynical children that understand math terms. And when I say something to my child about like, hey, I saw you went to the mall and you spent this amount of money, and then I saw you went here and spent this amount of money, and I think that, you know, you should like slow your roll on spending money. And then my youngest child, who's smart aleck, said, Mom, you've got a really, really small sample size on what I'm doing, like, thanks a lot, you know? Like, they know exactly what to say to me because they've done this. So you should not really be making any decisions based on just a couple of things. You know, moms, we do that. But also, I want to talk about this in terms of chapter 7 real quick. Do you guys remember in chapter 7 we had notes that said, oh, like I flipped right to it. It says, smaller variability is better. The larger the size of each sample, the less variable the sampling distribution will be, making a better chance of an accurate sample. More inner sample, more accurate estimate. Okay, so we started with that. And then we said, hold on, I gotta find the, oh, it's right here. What is the denominator in this? And what is the denominator in this? And what is the denominator in this? And what is the denominator in this? What happens when you increase the bottom of a fraction? The number's going to get smaller. Okay, so there's a common sense explanation in the fact that the more people you ask, the more confident you can be. There's also a mathematical explanation where sample size is in the bottom. So the bottom gets bigger, that means your fraction gets smaller. Does that make sense? Okay. All right, so now we're actually going to do math today. I know it's crazy. How do we calculate margin of error? And we're going to have some formulas. And it would be great, actually, if you guys got your yellow sheets out also. Okay. In order to calculate margin of error, I'm going to reach back into your memory and talk about the normal curve. Do you guys remember the empirical rule from first semester? So what are the two biggest percentages? 34 and 34. 13 point. Wait, wait. Isn't it 12.5 and 3.0 point? Oh, goodness. It's 12.5. Why can't I remember? It's because I didn't sleep again last night. I just can't seem to do the sleeping.
Like I'm about to pop up. When you're about to do it, you can.
13.5. 2.35 and 0.15. I got, okay. Great. Okay, so this essentially is a 68% confidence interval. It doesn't have to be located right here, though. As I demonstrated yesterday, it might not be right in the middle. You might get a sample that's wonky, and it might be here, and it might be here, and it might be here, but this would be the width of it. Okay, now knowing what you know, what would this one be? 95. Okay. Next question. How many standard deviations on either side do you get when you have 95% confidence? 2. Okay, which is kind of a lie. But I'm going to show you why that's kind of a lie in a minute. Okay, so can you guys all look at the yellow sheet? Yesterday we wrote point estimate plus or minus margin of error. And your yellow sheet breaks that formula down into 3 parts. So on the formula sheet, it says statistic, point estimate being the statistic. So for us, that's going to be P hat or X bar plus or minus. And then this is the part we're learning right now, critical value. The critical value in this particular example right here was 2. So meaning it's 2 standard deviations out on either side. If it was this guy, it would be the critical value would be 1. Do you see what I mean by that? So it's going 1 out on either side. Okay, and then times standard error of the statistic, which is the same thing as the standard deviation formula that you've been using, that you used in chapter 7. Okay, each of them have their own formulas. But what I want you to do on your blue sheet or on your yellow sheet, and this is something you're going to be able to leave on there. I want you guys to put margin of error. These 2 things multiplied together gives you your margin of error, which should make sense. So you have point estimate plus or minus margin of error. The point estimate is the statistic. The margin of error is made up of how many standard deviations you go out on either side. In this picture right here, it's 2 standard deviations. So 2 standard deviations. Okay, each one has a formula. And we're going to use our yellow sheet to kind of help us derive the formula. Not really deriving like calculus deriving, but okay. I'm going to use capital M, capital E to abbreviate margin of error because I am lazy. Okay, critical value has a new symbol. Okay, meet Z star. This is your new friend Z star. Now, why does Z make sense here? Yeah, so this is a Z score. And when you have the star on there, it just means absolute value. So this is 2 standard deviations away. It doesn't matter the direction. So this is Z star. Okay, and then find the standard error of the statistic for proportions. That's going to be right here. So this is the one that we did in chapter 7. So P1 minus P over N. Okay, now for means, margin of error, it's Z star is still the critical value for now. That's a, foreboding moment. Okay, and then the formula for means was right here, standard deviation divided by the square root of n. Okay, now, do you think that all confidence intervals need to land exactly on the whole number of standard deviations? No. As I said, the most common ones are 90, 95, and 98. Sometimes you'll see a 99. You need to be able to find Z star for anything. So this is what you're going to use your calculator for today. Z star is the same thing as absolute value of Z, meaning that you find what it is and you just make it positive. And the way we do that is inverse norm. And we're going to have to type stuff into inverse norm. So you're going to put parenthesis 1 minus your confidence percentage divided by 2, 0, 1. Okay, so I want everyone to try this. For 95%. And then you can see how I've been lying this whole time. So you guys are going to do Z star equals inverse norm 1 minus 0.95 divided by 2, 0, what? So here we go. You go to second vars for the distribution menu, inverse norm. You're literally going to type this in 1 minus 0.95 divided by 2, 0, what? You want either, it doesn't matter if you pick left or right tail, just don't pick the center. I'm going to do left just because that's what the calculator's default is, and I'm too lazy to change anything. Okay, I've been lying to you all year. It's not exactly 2. It's 1.96. How could you, Mrs. Talbot? I feel so betrayed. It really rounds close to 2, though. So back in chapter 1, when I said that this is exactly 95% and this is exactly 2 standard deviations out, it's not. It's 1.96. Oh man, the betrayal. So sorry. Okay. Do you guys have this part written yet? No? Okay. Not working. I'm now like tired. And then I go home and I get like the third wind and then I don't go to bed till like 10:30. I need to. You take me? No, let's try it again. I'm one of those people that has to take like large amounts of stuff for it to work. My husband takes like 5 milligram melatonin, he's like, ow. Like, oh. I'm gonna take a bunch of it. Do you think I should try it? No, I was gonna try, like, actually exercising. Ugh.
That can help.
I know.
Our mom used to do yoga with her bed. And that would help.
That was a lot of effort, more than like,
Easier
say,
than exercise.
laying on the couch watching Squid Game.
Yeah, that's easier than like a run.
Ooh, yeah.
Yeah.
I have 2 left. But Guy like spoiled it in the middle of lunch today. He didn't know. It's been out for a couple of weeks, like, I should have brought it up. It's my own fault. Anyway, okay. What the margin of error does and does not account for. I know there's a homework question that asks this. So margin of error accounts for only one thing. The only thing it accounts for is variability due to random sampling. It does not account for bias in the design of the survey or the experiment or the study. Most of the time, you're going to have voluntary response problems, under coverage, and non-response. If I were you, I would keep the chapter 4 vocab thing in my folder all year if that was the one thing I was gonna keep in there, other than the yellow sheet. So, just because they're gonna ask you like what type of bias might be in these different types of studies. And so it might be like, remember like desire to please and stuff like that. So margin of error, it just means that when you blindfolded Mrs. Talbot and told her to reach and grab 10 Squishmallows, that she's gonna grab 10 different ones each time. It doesn't mean that, how could there be bias in me grabbing the Squishmallows? Like if you put me really close to the pile of big Squishmallows, I don't know. You get what I'm saying though, right? It's just because of how random sampling works. It's not because your design of your study sucked. And so you're like, oh, my margin of error is gonna fix everything because I don't need to worry about bias anymore. Okay, next thing is the arts and crafts, I believe.
Oh, under that. Yes, bro. No, like, make sure that
Is yours the purple one or the blue one?
Literally not. Make fun of Jamie. My teacher said.
I don't understand why nobody made me a sock thing. Don't you think that would be the first thing that comes to mind? But nobody made me one. It's fine.
They're so cute. I just,
Probably not really gonna get colored like that.
the funny thing is, I should just like show up in the class one day and just be like, yeah, yeah, exactly. Why is Mrs. Talbot in here?
Three.
That's so funny. Oh yeah, you should take it to med and give it shots and stuff. Suction out its nose. The worst part of baby parenting. Yeah. Finish D and an E.
That's it.
So are you waiting the close comment?
Okay, you guys, it's okay to keep talking, but I want you to do A in your group, please. You should be able to calculate the point estimate and margin of error yourselves out of yesterday's and in the homework. And it's super hard, it's adding and stuff. I know, my expectations are ridiculous. How could you, so mean to us? Did you do it already? Was it that easy? Did you do it? Yep. 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 Okay, check your answer when you're ready. I drew the picture. Put a 90% there on purpose because I want to talk about that in B. Point estimate 0.56. Margin of error is 0.16 on either side. How are we doing? We good? Okay. You're still what? No, sorry.
Okay, you guys, so I want you to, again, we talked about this yesterday. I want you to take what what happened? What happened? What happened? What happened? What happened? What happened? No, no. Was it there? Was it there? There? Okay. Um, okay. So you guys, can you all imagine the curve over top? And because this is 90%, this would cover 90% of the center. Does that make sense? Okay, now I want to use this logic to talk about what would happen to the width if it increased to 99%. It would cover way more of the curve. If I increase how confident I am, that means I need to widen the range so that I can still be pretty sure I'm correct. So if I want to increase my confidence, I have to widen my range so that I can still be pretty sure that I'm correct. Okay, so increasing how confident you are increases how wrong you might be. Just like Garfield, super confident, but it could be really, really wrong. Okay, now this is the next thing. If you write C, I want you guys to do this one on your own. I want you to calculate Z star for a 90% confidence level and then a 99% confidence level. Practice doing this in the calculator. And then compare them, see that it makes sense for the pictures that we drew. I'll give you a hint. This is how you start. Also, if you have a newer calculator and you go back to, you can actually scroll up and just change this number. Or if you go back to inverse norm, it'll still be in there. By the way, this is a quick hint. This is not cheating. If you leave this in your calculator, you will not have to memorize it for the test. You see what I'm saying? So if you go into inverse norm and type the parentheses, put 1 minus like 0.95 divided by 201, and you use that same calculator for the test, it'll be in there when you go open it back up. And all you have to do is change the 95 to whatever percent confidence you want it to be. Also, you can do that on the AP exam. They're not going to check or make you reset your calculator. So if I were you, I might throw this into inverse norm beforehand. Okay, and remember, it's absolute value. That's what the star means. So these are always positive. Okay, you're wondering maybe what to round to. For 90%, we use 1.645. By the way, this is always the Z star for 90%. You don't ever have to do it again. You could just come look at this paper. Every time you do a 90% problem, you could just look at this. You could do it in the calculator, but these don't change from problem to problem. So this is just what it is. Okay, what does that mean? It means that you have to go out 1.6 standard deviations on either side to get to here. Okay, did you do the other one yet? What did you get? Yeah. Okay, so do these numbers make sense in terms of my pictures? So this is saying you need to go out 1.645 standard deviations on either side. This is saying you need to go out 2.576 standard deviations on either side. Does that make sense, like intuitively, common sense wise?
Yeah.
Okay, and also, do you understand how to find Z star? Okay. Okay. We have two more and the things, and then we're done. You'll definitely memorize the 95% one. It's just gonna happen. Okay, last thing. Explain what would happen to the width of the interval if the sample size was increased to 100. Okay, sample size increased. Is that good or bad? Good. Okay. And would that make error more or less? Less error. Okay. So what would happen to the width of the interval? Mm-hmm. Great. I can hear you. Okay, now this is not done. This is true. Um, can somebody intelligently tell me how much it would decrease exactly. So we know the width would decrease. The sample size is going from 25 to 100. Yes,
By a factor of two,
yes, by a factor of 2. Why is it?
because it's increasing by a factor of 4, so you square root that.
Genius, genius. So all of the sample sizes in the formulas are underneath square roots. So it's increasing by 4 times. And the square root of 4 is 2. That was on your last test. Do you guys remember? A lot of people answered that wrong. They put 4 times instead of 2 times. Okay, last question, favorite one of the day. Describe one potential source of bias that would not be accounted for in the margin of error. Look back at the problem. What's wrong with this scenario? These poor children. Did you read it and think that's just not right? Yeah, they had to say it out loud. Okay, what would be the problem? What potential source of bias is there? Desire to please. Okay, now would you expect because what? Too high, right? Everyone would overestimate, right? Because no one's gonna say that they've got that 1.2 GPA.